Thank you. I want to share with you two stories that inspired the title of this talk. Smaller is better. And I want to start with the big, Texas big. In case you have never been to Texas, everything is bigger in Texas. Freeways are bigger, even cups of soda are bigger, and you need the cars to hold the cups. So there you go. And at first I thought that the cars were so big because, well, you need cattle, you know, to be carried from one place to another. But actually there's not so much cattle being carried around, and there is mostly one person going from one point A to point B. And I think we can all agree that the more efficient way of transporting people will be to go in small cars. But no, not in Texas. Everybody wants to have a big car. Even people who cannot afford them wants to have a big car. So this is ingrained in the Texas culture to have a big car, so much so that it has become a cultural legacy. 14 years ago, the governor of Texas became the 43rd president of the United States. And this bigger is better culture got reinforced to a higher level, and in a way even spread a little bit in Europe. Now I want to move to the other story. This is about the small. And it takes place in Hungary in 1951, right at the beginning of the Cold War, when suddenly there is a flu epidemic. And this flu epidemic makes basic laboratory equipment to be depleted, and basically there is a shortage around the country. So these are equipment that you need to process samples to be able to treat people and to actually study the virus. And a 37-year-old physician then, Dr. Giulia Takatsi, came up with a very simple idea. Let's make everything smaller. All the vessels and containers that you need to process the samples should become smaller so that you can do this more efficient and you don't use so many of them. So he actually made the containers out of glass and metal that could be cleaned and reused. And by doing that, he had the whole setup of his lab being more efficient in the sense of the time, labor, and the amount of lab space that he was using. With that very simple concept. This later became a huge business, but people didn't hear about this invention through regular channels. They heard about it through people who escaped communist Hungary and told the idea to scientists in the West. And those scientists and companies copied the idea and developed a whole market around it. And this has been basic technology used in major discoveries in life sciences since then. Two examples of that are DNA technology, like PCR, and another one is the idea that you can do, through high-throughput screening, thousands of experiments in areas the size of a €2 coin, of a $50 cent coin. That's a lot. But what is important to see here is that these are standards that are used every day in research worldwide, all in the concept of making everything smaller to be able to do more. There is a problem, there is a model that we can learn from this, and it's about how a sustainable innovation comes to market. From the idea of Takatsi, for example, there is an individual that had a necessity, a need, and came up with a sustainable solution. But there is a problem with this model, and I'm going to tell you about it later, so bear with me. Before that, I want to tell you a little bit about my research. I'm a stem cell biologist, and I study, like thousands of people around the world, basic stem cell biology, and look for applications where we can treat with the cells diseases in various parts of the body. You may have heard of examples of these, such as people trying to make skin cells to be able to cure patients who are burnt. Others are making intestines to replace whole organs. I focus on making brain neurons, which may, like this one, which may one day be used to treat a specific brain disease. But after all this work in the lab, we have to think of ways of actually testing it in a relevant model, and those models are animals. And I bet that every one of you has an opinion about animal testing. This is controversial whether you are developing medical treatments or testing lipstick. And it is a practice that is not likely to change because we cannot go from the lab to people directly. But there is a way that we can compromise about the numbers of animals that we use. When I was at the end of my PhD studies, I wanted to test one fundamental question, and it was, would different amount of stem cells create a different type of tissue? So I came to the point where I had to test my own experiments in an animal to be able to know if my results could be used, or, well, could be of practical use, basically. And what I had was a container, which is the size of the diameter of a pencil, where I could put the cells, put them in the animal, then leave it there for weeks or months, take it out, make sections, and these sections are the ones that you see on these 9 figures in this slide. And then, once you have them there, you can use markers. You see 3 markers here, but in principle, you can use dozens or hundreds of other markers. And then decide whether you have a particular type of tissue or not. The one thing you have to see about this is that it is a huge piece of tissue. Even if the diameter of a pencil doesn't seem like much, it is a big piece of tissue to take pictures of. And then you have to decide which pieces are relevant, which is not relevant, based on color. It is kind of subjective. And in many ways, it's like taking pictures of a comet that is, where there is a probe that has gotten lost. If you heard the news last week, in case you didn't hear them, there was a probe that was sent and was landed by the European Space Agency on a comet very far away. But the problem was that they lost and they didn't know where the probe landed. So they started taking pictures of a dishwasher-sized probe on a comet the size of the Mont Blanc. This took a few days and a few thousand people to figure it out. And while this is not as dramatic as that, it does take a lot of effort to be able to come up with all these pictures in a reasonable amount of time. And this is the key because, as I told you, I was at the end of my PhD studies. So I had limited funds, I had to start looking for a job, and I had no time to waste in doing all these experiments this way because I could only use 4 containers maximum in one animal. And then I had to do all the pictures. This would have taken me years. So I thought of a different solution. And this was to do exactly what Dr. Takatsi did. In order to use animals more efficiently, what we decided to make were small containers where we could hold the experiments in one animal. Now, this is using and showing rapid prototyping techniques, which are best described by Tom Chee's Rapid Prototyping TED. You should check it out, it's really cool. But the basic idea is that you make these wells or containers where you hold the experiments, and we can make them with materials that are inert, that they don't have any influence on the animal, at least not negative or positive. And then you put the stem cell concentrations in each one of these individual wells or containers so that then you can put them in the animal. Same thing, you wait for weeks, months, and then you take them out. The bigger the animal, the easier it is to pour more experiments into it. So in principle, the more animals that can be saved as the species or the size of the species is bigger. And that is the concept. But how does this work? Well, I used a similar model, putting 4 of these devices in one mouse, but with the difference that each one of these devices had 9 containers. So for a total of 36 experimental conditions in one animal. That's already 9 times savings in the number of animals that I had to use to run the experiment to be able to account for statistical significance and whatnot. And same way, you leave it for a few weeks, then you take it out, we make slices, we put them on a microscope slide. But the big difference here is that we have, and you see here 3 different slides, right? And we use the markers that we used before, but you have 3 conditions on one microscope slide, and this can be also many more. And that allows us to use a very small amount of reagents already on 3 experiments on the same animal. That is very nice because you account there for the variability that you have in experiments with respect to the different members of a species. Also, Because we made a small container, this allows us to make very efficient use of our resources, in this case, stem cells. Stem cells are cells that are very few that you can gather in the lab. So we usually have to think of how we make these, how we can optimize their number. And by making the container small, what we were able to do was to decrease the volume so that the concentration will be higher and it will be physiologically relevant. Now, what we did with this, as an example, was to make blood vessels, because we had so many stem cells per milliliter that this started making blood vessels, as you can see in green on these spots. So until now, what I have described to you has a lot of different aspects with Takatsu's idea. You have an individual who runs into a need, a problem, and that individual comes up with a sustainable solution. But should we really need to have oil become depleted, or we really run into these needs before we come up with sustainable solutions? That is really the problem that is going on. That it is, these sustainable innovations are being driven by individuals and are not part of cultures, are not part of organizations. And that is a problem. Should we have to have a refugee from a communist country go and tell the world about an invention before it becomes something sustainable in the mainstream? It shouldn't be like that. And it shouldn't be like that, and it is already causing us trouble, and it's close to becoming a need to change the practice of animal testing. The big picture of this is that out of all the drugs and treatments that are tested, only 11% actually make it to the pharmacy, to the clinic. So there is a huge waste in animals and other resources. This 89% is wasted, but somehow you have to find the money to be able to cope with the loss. So this is driving health costs higher and higher all around the world. It is estimated that and projected that for the next 50 years, costs in healthcare will increase worldwide in both emerging economies and rich countries alike. We are using hundreds of millions of animals every year to do the experiments that can cure our diseases. And it's not like it is really making a difference from the numbers that you see. These are not animals that are all really being successful in developing clinical treatments. We are running into big waste in doing those experiments that way. But I have shown you today that there is a way that we can decrease these numbers by a lot by applying the concept of smaller is better in scientific research and specifically in animal testing. Last but not least, I want to encourage each one of you to think of ways that you can apply the concept of smaller is better in your own lives, because you can also make a sustainable contribution to the world. And I thought that was an idea worth spreading. Thank you.